Bismillahirrahmanirrahim. Assalamu alaikum everyone. I am Mahasharazi, your computer teacher. This is your assignment number 8 of computer science subject. So in the previous lecture we have studied about the conversions, that how can you do conversion from binary to denary, denary to binary, then converting from binary to hexadecimal and from hexadecimal to binary. And we have done different type of activities regarding to the related topics. Now in today's lecture we are going to start our lecture from page number 20, and the topic is converting from hexadecimal to denary and from denary to hexadecimal. So to understand this topic we are going to watch a video, and after that video we are going to start another topic.
So far we've learned how to convert from a denary number to a binary number, which is great. We've also learned how we can do that the other way around. We've learned that we can convert a binary number to a denary number. We also know that we can convert a binary number to a hexadecimal number. Let's write out hex for short form. And we know we can convert a hex to a binary. So hopefully we can see the system that if we can convert from a denary to a binary and from a binary to a hex, then we could actually take any denary number and convert it into a hexadecimal number by first of all converting it into binary. And this also goes the other way. We can convert hex straight across to binary by converting through, from hex across straight to denary by converting through binary. So let's see if we can have a go at taking a denary number and converting it to hexadecimal. So I'm going to start off with a denary number. Let's make one up. Let's say 215, and I would like to convert that into a hexadecimal number. But to do that I'm going to want to convert it as an intermediary into a binary number, and that's what I'm going to do as my first step. So to take 215 and convert it into binary, we've done this before. Let's draw out our table. So I'm going to say 1, 2, 4, 8, 16, 32, 64, 128. Need to get 215, so I can have, let's just make my columns nice and pretty. So will 128 go into 215? Yes, and that means I am up to 128. Will 64 go into this? Well, if I add on 64 here, 4 add the 8 is 12, 2 add 6 is 8, add the 1, 9, and the 1 on the end is 192. Yes, because 192 still isn't up to 215, let's add that on. Now up to 192. If I add on 32, where will I get to? 1, 2, and 3. 2 add 2 is 4. 9 add 3 is going to be 12. 1 add 1 is 2. That gets me to 224. That's bigger than my 215, so I do not want you 32. Still stuck then on 192. 192 add 16. 2 add 6 is 8. 9 add 1 is 10. 208. Yep, that works for me. So I'm going to say I will have the 16, and that gets me up to 208. Can I add an 8 to that? Well, 8 add 8 is 16, so I can already tell that that's going to get me beyond my 215. So I'm just going to say no to that and make 208 again. You can still write this out if you feel more comfortable, of course. But as I say, I know that's going to get me 216. So let's keep going along. Can I add the 4 onto 208? Yeah, that's going to get me up to 212. So I'm going to do that mentally here. 2, 1, 2. Can I add on 2 to that? Yes, I can. So that gets me up to 214. Can I add the 1 onto that? Yes, I can, which gets me up to my 215, my end number. So in here, all we've done is we've converted 215 from the denary number to the binary number. So the next step is, how can I convert this binary number into the hexadecimal number? Now you can choose how you want to do this on paper. Some of you may prefer to write this whole table out again, and I think if you've got time to do that, it's probably advisable. However, I'm going to kind of shorthand this and just write this a little bit smaller and simpler. This is a bit faster, but again, you can decide how you'd like to do this. So the numbers down here are going to become pretty useless to me now, so I really want to disregard all of this and don't want to get confused with it anymore. Let's get rid of all that. I know that I've got 1 to 8 up here, so I know this is half of my hexadecimal number, and I need to have this half as well. But I'm aware that this number system isn't quite right because I need to treat this back to 1, 2, 4 and 8. So I'm just going to scribble out the unnecessary numbers. So now I've got 8421, 8421. Now I've got a position I can work with. Again, this is getting a bit messy, but you can see how I can keep with the having to rewrite things out so much. And to be fair, there's room for error doing that as well. So let's just add these up then. So 8 add 4. Well, 8 add 4 is 12. And don't need to add on the 2. Add 1 is 13. It's 13. Just write that there separately for 1 second. I've then got this set, so I've got 4 and 2 is 6. Add the 1 is 7. And that would be my hexadecimal number. Apart from, there's no 13 in hexadecimal. So let's quickly remind myself of what 13 is in hexadecimal. Well, 9, 10, 11, 12, 13, which means that's 9, A, B, C, D. So I know this is D, so that's D7. So in total now I can say that 215 is equal to D7 in hexadecimal. So in the last video we took a denary number, we converted it to binary, and then converted that into hexadecimal. So we took a denary and made it hexadecimal. In this video we're going to go the other way. We're going to start with a hexadecimal and convert it into denary. Let's carry on actually with this bit of paper for this one. So the hexadecimal number I'm going to start with, let's just say I would like to start with 5e. And we're going to convert 5e back into a denary number. So to do that, as we can see from our little chart here, we're going to need to convert it into binary first. To do that, we're going to have to look at it as two separate parts. So I'm going to take the 5 and convert that into our system. 1, 2, 4, and 8. And I'll need to do the same for the e as well. Oop. 0. Mess that up. 1, 2, 4, and 8. So to do the 5, we're going to need 4 and 1 will make 5. Pretty comfortable with that. And to make e, well, what is e? 9 and 9. A, B, C, D, E. That's 9, 10, 11, 12, 13. It's 14. So I need to make 14 out of these numbers here. So let's go with 8 and 4 is 12. Add the 2 is 14. Don't need that one there. And to simply string that together, not forgetting to put my extra zeros in, I could say that 5e as a binary is 0, 1, 0, 1, taken from here, 1, 1, 1, 0, taken from over here. Now I just need to simply convert that into a denary number. Well, we know how to do that, that's quite straightforward. Let's write out 1, 2, 4, 8, 16, 32, 64, 1, 2, 8. And we'll just make our columns tidy. And we'll write this back in here. So 0, 1, 0, 1, 1, 1, 1, 0. Now we've got our set of numbers that we need to add up, which is 2, 4, 8, 16, 32, oh, not 32, and 64. So again, using any multiple addition method that you are comfortable with, I know I've got 64. I know I've got 16, I've got 8, 4 and 2, 8, 4 and 2. So 4 add 6 is 10, 18, 19, 20, 21, 22, 23, 24, 4, 2, 6 add 1 is 7, 8, 9, 94. So I can safely say now that 5e is equal to this binary number, which is equal to 94, this denary number. Now you can see you end up with a lot of working here. Please, when you're doing this in an exam, make it very clear to the examiner your actual end answer. So I might just do at the bottom of my exam paper, or where the answer is required, 5e hex equals 94 denary, just for clarity.
So I hope so that you have learned properly that how can you convert a hexadecimal figure to a denary number and from denary to hexadecimal number. So this section reviews 5 uses of hexadecimal system, and the information in this chapter gives the reader sufficient grounding in each topic at this level, and further material can be found by searching into the internet, but be careful that you don't go off at a tangent. Now the next topic is memory dump. Since it is much easier to work with B5A41AFC rather than 10000 and so on, so hexadecimal is often used when developing new software or when trying to trace errors in program. So the content of the part of computer memory can hold the key to help solve many problems, and when the memory contents are output to a printer or a monitor, this is known as memory dump. Now the next topic is Hypertext Markup Language, HTML. HTML is basically used when writing and developing the web pages. HTML is not a programming language, but it's simply a markup language. A markup language is used in the processing, definition, and presentation of a text. And HTML uses tags which are used to bracket a piece of code. For example, bracket td bracket so starts a standard cell in an HTML table, and it ends by using this command bracket /td bracket close. So whatever is between the two tags has been defined. You can see it in HTML code. Now the next topic is Media Access Control, which is also known as MAC. So a Media Access Control MAC address refers to number which uniquely identifies a device on the internet, and the MAC address refers to a new network interface card NIC, which is the part of the device, and the MAC address is rarely changed so that a particular device can always be identified no matter where it is. Okay. Now there are different types of MAC addresses. It should be pointed out that there are 2 types of MAC addresses: the universally administered MAC address and the locally administered address. The UAA is by far the most common type of MAC address, and this is the one set off by the manufacturer of the factory, and it is rare for our user to want to change this MAC address. However, there are some occasions when a user or an organization wishes to change their MAC address, and this is really easy task to carry out, but it will cause big problems if the change address is not unique. Now the next topic is web addresses. Each character used a keyword has what is known as an ASCII code, American Standard Code for Information Interchange, and these codes can be represented using hexadecimal values or decimal values, and this can be shown as a part of the ASCII table. Now the next topic is assembly code and machine code. Computer memory can be referred to directly using the machine code or assembly code, and this can have many advantages to program developers on when carrying out the troubleshooting. Machine code and assembly code are covered in much more detail in chapter number 7. Here we are simply interested in how hexadecimal fits into the picture. Using the hexadecimal makes it much easier, faster, and less error prone to write code compared to the binary. So using the true machine code is very cumbersome, and it takes a long time to key in the values, and it is also very easy to mistype the digits in a sea of ones and zeros. Machine code and assembly code are examples of low-level languages and are used by software developers when producing, for example, computer games, as you will find in this chapter 7. Although they look cumbersome, and they have many advantages at the development stage of software writing. So this was all about today's lecture. I hope that it will be easy for you to do the conversions, and further topics are also very easy, and inshallah you will do the respective activities regarding to these topics. So take care of yourself. See you in the next lecture. Till then, Allah Hafiz.